Hi, welcome to 505 Videos. This is DC here. In this video, I'm going to show you how to use ISO15693 tags using PN5180 board. So you must have a bit of a background before you start this video. Now you have to know how the ISO15693 protocol works. I have made a lot of videos almost 20 months ago explaining the basics of ISO15693. I would advise you to see my playlist called ISO15693 tags and the reader writer in YouTube. So in this playlist you have got around 12 videos. I covered right from understanding the specification, the protocol, and also I've showed how to use ISO tags using the readers that supports ISO15693 tags. Now in fact, I am going through these videos to understand this concept because the last time I came to know about ISO15693 was almost 20 months ago. Now in this video series, I've also showed how to use these tags using the OmniKey reader writer as well as the CR95HF development board. Now this video series, this has got so many things are covered in this, and probably I'll not be covering these things in my latest videos. So you must have with you the ISO15693-3 specification document which you get from internet. And what I would like to cover in this video is show you the tag that came with the board. If you have purchased this board from internet, it's most likely that you'll also receive a tag, and the tag is called iCode2. Now this is in fact a NXP iCode SLI tag. So I don't think this is SLIX, probably it is SLI tag. So you're going to learn how to use this tag, and you're going to see how to activate these tags, how to read and write, and what are the commands that are used to read and write. And you're going to learn what are the request flags and the response flags, and also how to lock the blocks. And as I mentioned before, I have covered everything in detail in this playlist, so I would advise you to see all these playlists. Even in fact, as I mentioned before, even I myself I'm going through all my videos to understand the document. And I'm sure you like playing with the ISO15693 tags. There's so many things you're going to learn in the video series. So you can see here I've connected my PN5180 board with Arduino, and this is the software I've been using in all my videos. Now this software has gone to the version 1.6, so there are so many things you will see in this software which there is no video. So my developers are going faster than I could do the videos. If you see the release notes here, the last video I did was on how to use the MiFair ultralight tag. After that, the developers have added ultralight EV1 and NTAG 213, 215, 216. You also have the SRIX tags, and the latest one is the ISO15693, the iCode SLI. Now this is what I'm doing this video on. Now these missing functionalities, I'll be doing these videos very soon. So however, the reason why I wanted to do video on this iCode tags is, now there are so many reader writers and boards that work with the MiFair tags, all these tags. However, there are not many boards that supports the ISO15693 tags. So that's one of the reason, and also there are not many videos on how to use ISO15693 out there. So I thought, by doing these videos now, probably you'll get enough time to master this concept. So I made tons of videos on how to use all these various tags. I would advise you to go to my Farnet Pi video channel in YouTube, and if you already have this software, you can start using all these tags, because the screens are more or less the same, what you see in my videos on this as well as the video on the screen in this software. So this is the tag you might have received when you buy this board. And just one more thing I would like to say, so if you have used this this board called the MFRC RC522, and if you're new to RFID and if you want to do any embedded programming, I would advise you to go with the PN5180. That's this board. So this MFRC522 does not support ISO15693 tags, whereas this thing supports. And also the cost difference is only between what you pay for this board. So if this costs you say £3, probably this board will cost you around £6. So you still need your Arduino Uno, you still need all your cables. So just by paying a couple of pounds more, you will end up having a board where you can also learn the ISO15693 tags. And also the programming wise, if you've seen the Arduino library for this, and you can see that the programming is much easier in PN5180 compared to the MFRC522. So I would advise for students and newcomers to go with this board instead of that one. So if your intention is not to use this ISO15693, then probably you can save few pounds and you can just go with the MFRC522, or you got the PN532 as well. So first I'm going to show you how to do various read and write operations on this tag. And I've been using this tag already, so you will see some data already written. Now after you connect and if you choose this drop down list, you can see there is entry here for ISO15693. Now you have to first, because this is a learning software, you have to know that you have to turn on the RF antenna. So first click the RF on, you will see a message here, then click on activate. You can see this is the 8-byte tag UID. If you go to the system and click get, and if you're using this for the first time, please follow the same order what I'm doing here. Now once you master this concept, you can just go in any random way you like. But because the reason I mentioned that is because this software is still in the early stage, and you just have to follow. It's not complete, I would say, but it does its job. You can still learn a lot of things here. So as usual, in the command section, you can see all the commands going from here. Now these commands, the first command A1, you can just ignore that, but remaining after that is your PN5180 command, followed by, now sorry, this is not a PN5180 command, this is the IS15693 command. Now in the later part of my videos, I'm going to show you how this coding has been done in the Arduino side. But these commands, what you see here, they are ISO15693 commands, and as I mentioned before, you have to have the protocol specification of this tag. So after you hit this, when you hit this get button, the command called get system information retrieves a lot of information here. It tells you who is the manufacturer, what the type of the tag, and this is the type of the tag, from the manufacturer point of view, not in general type. It also tells you how many blocks of data, how many blocks are present in this tag, because this tag is an I-code SLI. This has got 28 blocks and each block is 4 bytes. Now all this information is encoded within the tag, and you can retrieve that by passing the command called get system information. Now you get a series of bytes here which has been decoded, and that's what you see here. This is the called request flag. Again, you have to see all my previous videos. Every command starts with the request flag, and you have to have at least the default flag which is ticked here. So you have to have this bit 1 ticked. Now this is the high data rate bit, and you're going to learn in detail about these things. You got a flag for subcarrier, whether to a single or a 2, data rate, inventory, protocol extension, select, address, and if you click on the inventory, automatically you'll get a different bits here. And again, I have covered most of the things in my videos. I'll try to use this in my future videos as well. Now I'm not going to use this. The first thing you would do is using this default flag, you just go and hit the read tag. Now read tag, you can see it sends a series of read single block. See, read single block is a ISO15693 command, and you can see that every command starts with the flag, the request flag, which is here. As soon as you make changes to this boxes here, you can see the value of the hex. Now this is what you need to send with the command. So this request flag followed by 20, this is the read single block command followed by the block number. Likewise, you got block number 2, block number 3, and in return you get, in fact you get only 5 bytes here, because this is sent by the Arduino program. Now you should receive these 5 bytes. The first byte is the response flag. If it is 00, it's a successful command. Otherwise, if you get a 0, 1 or 2, this indicates an error. In that case, you will not have any data. So for every single read block command, you will get the block data, which is 4 bytes. Now here within the grid, you can see I provided 3 links here: R for read, W for write, and L for lock. Now you have to keep in mind, locking is a one-way operation. You cannot unlock any block. And again, it's a very interesting, the way this command structure works is so interesting. So when I did the read tag, you just get the data. However, I'm going to do the same read operation, read entire tag operation, by choosing this option tag, by putting a tick on the option tag. Now you can see that the flag value has become 42. There's no magic happening here, it's just a binary equivalent of this these flags. I'm going to clear this time. If you say read, so what has happened is, you can see that you started to see the locked blocks. Now when the request flag has got a 1, the tag returns you 6 bytes. It's not just 5 but 6 bytes. The first byte is still the response flag, which is 00, followed by 1 byte that tells you whether the block is locked or not. Again, if you read the documentation, it's so easy, so simple to understand from the document. So response 0, 01 is the locked, and you can see block number 6 over here, which is locked. If you compare that with block number 7, which you get the 0 here, and this is not locked. Now it's very easy. So that is how you read this entire tag. But you have to keep one thing in mind. As I mentioned before, this is still the first cut of the software. If you have got a different tag, say if you want to try the software using the Texas, the TA tag, okay, so you will see a little bit of difference. Okay, so I'll tell you later about what the difference are. So I'm going to show you a different way of reading this entire tag data. This is using what is called as a multiple block command. I'm going to activate again. So start with the RF on, click on the activate. You should see the UID, and go to system, then click on the get. You should get the system information with various sizes, and also I'm going to mention this about this in a minute. So here I'm going to use the multi-block. if you hit this and say read the tag, now this is much quicker. Now it's obvious because I have used a command called read multiple blocks. So here again, this is the block command structure. This is the request flag. This is the command byte 2323, and this is the starting block and the number of blocks you want to read. So you have to again refer to the documentation where you understand, it's very easy explanation in there as well. Now only thing you have to be careful here is the number of bytes you get. So here with this tag I'm okay because this returns altogether maybe 120 bytes. If you try this on a Texas Instruments or a different tag, this software may not work. So that's simple to say, because at present the software doesn't handle more than 255 bytes. So that will be fixed very soon. So just try to keep in mind. So in that case, if you're trying with the different tag, do not use this multi-block. You can still read entire tag by unticking this and hitting the read tag. Now what we have just seen here is how the multiple block command works. Now you get lots of data here, which again it is decoded and put on the grid. Next I'm going to use this multi-block, but this time with the option thing. Again, what you have to notice here is the very first byte is a response. This is followed by series of bytes where the 4 bytes belong to the block. The first 4 bytes belong to the block 0, the second 4 bytes belong to block 1, and so on, and the last 4 byte belongs to the last block. Now if I enable the option flag, we know that when option flag is set, the tag returns in addition to data 1 byte which tells whether the block is locked or not. Now I'm going to try that. Oh, sorry, I should have clicked this thing. Now I still want you to, I'm going to delete the rest if I can. Yeah, now I'm going to choose that, and look at that. The difference between this and this is you got more bytes. Again, you have to keep in mind the total bytes should not exceed 255. So here after this response flag, every 5 byte belongs to a block. So I know that first block, the 0th block, is locked, so you'll have the 01 that says it's a locked block and it's 4 bytes. Then you got 00, that's the unlocked block, the block number 1, followed by its own 4 blocks. So it's very easy. So if you get a chance, you can use this read multiple blocks rather than sending a series of single read block. So that's all about reading. Next I'm going to show you how to write. Now writing in this SLIX tag is pretty simple, but if you try to write in a Texas Instrument TA tags, they're different. Now I'm going to make my next video probably will be on how to write with the onto a tag it, the TA tag, but here the write is very simple. Now keep in mind you have to see the documentation of SLIX I-code. So during the write operation, having this option ticked and unticked has a lot of difference. Now this particular tag, SLIX tag, says you cannot have option ticked for the write operation, but if you see the documentation of the tag it, the tag from the Texas Instruments, it says write operation is possible only when the option flag is set. Now that's a different story altogether. Now let's keep this the write simple. Now this SLIX I code is pretty simple in that way. Now I want to change the value of block 7. I'm going to change this as 1 to 13. These grids are editable, as you can see here. Now I'm going to, let me clear the screen here. Now I'm going to write. Now you see the message, write block okay. If you look at this here, now the 00 is the response you got, that indicates success. If you try to read, you can see that whatever we just wrote is you're able to read. What if you try to write a lock block, which shouldn't be possible in theory, but let's try to do that. 04. When you say write, Now this time, there is an error because there's no response coming from that. Now when there is a write error, there somehow I was expecting some kind of error here, but however the write failed. If you try to read, you got back the old data. The good thing about this ISO15693 tags are, compare what would have happened on an MeFair Classic or Ultralight. Every time you end up trying to now write to a log block, you have to reactivate the tag. Here it's not like that. The tag is still live and activated. You can just keep sending the commands. There are plus and minuses with this concept, but however you just have to accept what the tag is doing now. So you just saw the write, how the write can be done. The next thing is, I'm going to show you how to lock a block. Now make sure again, you keep in mind, lock, you cannot unlock it. Now before you lock, make sure you have written the data you want in the block. Now I'm going to lock this block number 7. So you just have to hit this. Now I was expecting, I think a kind of a warning would have been better here, because once you lock, it's all gone. So here the response is, this is the lock command. Again, the documentation says it's the request flag and the lock block command followed by the block number, and the response is 00. So the lock is locked. Now if you try to read, now a normal read will never return the value of the lock bit, which is this log byte is also called the security flag. Then in order to get whether the block is locked or not, you have to send a read request using the option flag ticked. Now when you say read, you can see that it's locked. So likewise, most of these 15693 tags, they do support AFI and the DSFID. I mentioned about this in early videos also. However, I've covered in much detail in my playlist. Now this application family identifier, every tag is given an ID which you can use during inventory. Now I'm going to show you how to change this thing, because you can't do anything more than, because I'm not going to show you inventory at this stage because it's too early. So assume that you want to change the AFI of the tag to 06. So if I set, again a warning would have been better. So right AFI is an error here. 1 second, let me try why it is. It is because the write operation has gone with the option, and you have to make sure, and you have to remember that in this SLIX iCode SLIX tag, you cannot send the write command with the option flag set. So I'm going to try this again. Now this time it's fine, successful. Now there is no command to read AFI. The only way to read AFI is to get the system information. If you click, the best thing, I'm going to show you how I'm going to change this as well. Say 02 is my DFID. Set, that's successful. I'm going to close. I'm going to take out this tag out and try all over again. Place here. I'm not sure whether this is required, but just give activate. Yeah, so you don't have to if you remember that RF is on, you don't have to do that again. So go here, look at that. So we have got a modified AFI and DSFID. So if you have seen my, if you use this type of tags, this tag also supports lock AFI and lock DSFID. And also this tag also supports what is called as EAS feature, which probably is going to come to this software pretty soon. So so you are able to change. Then I'm going to, yeah, what we have to keep in mind is there is no way to read, no command to read AFI and read DSFID. You have to hit this or send this in a get system information command. Now next I'm going to show you what changes has gone into the Arduino. Now as we have seen before, for every command that comes from the software, there is an entry point here. Now this is the front end of the software which runs on the Arduino. So two case statements are added for ISO15693 tags. So that's one is the finite pi send data with the weight and without the weight. And there's a lot of delay command used within the software. Now in this case, the delay is prefixed to predefined to 5 microsecond, whereas here you can change the delay. So I'm going to speak about the delay in my future videos, so you have to know about this feature. Now there's only one function which is available in this file called ISO15693.cpp, and this is the function. Now there's only one PN5180 command that does all this job, that is the send data command. See how cool is that? Because the piece of software sends the entire ISO tag, and everything the software sends is passed on to the tag, and any response you get, okay, is returned back to the software. There are some kind of a clever programming has gone in as well. So I'm just going to walk through this code. So this is the setting up of the command structure. So we are using the number of bits in the last byte as set to 0, and these are the things is always used. And here, after sending this entire command, the software loops until it gets some response. Now kind of a trick here, probably this is because we are still not comfortable with various timings and the signals and the bits. So but this logic work for us. As soon as the command is sent to the tag, there is a small wait happening in Arduino. Then you look for how many bytes are received, give one more small wait and read the number of bytes second time. If these two values are different, that means still more bytes are yet to come. Now you have to have these type of things when you try to use the multiple block read, where you get hundreds of bytes from the tag. Now the byte received is incremented, it's updated incrementally. So assume that this is the tag, and you requested a read multiple block, and the tag is trying to send, say, 250 bytes. Now on the PN5180, this is the tag here. On this 5180 side, so there is a counter which I've spoken about in my previous videos. Now this value keep incrementing as and when the bytes are received from the tag. So that's the reason why there is a loop going on. Now once the length of the data received in both the cases are the same, it means the entire read bytes is successful, and everything so basically this loop is there just to find out how many bytes have been received from the tag, and after this loop the next command is read so many number of bytes. Now that's all. This one single function is what has been used in all the commands you saw in the earlier part of this video. Now bit interesting, probably gradually, once more and more about all those bits and pieces in the document, probably this might change. So that's all I've got in this video. I hope you like this video. In the next video, I'm going to show you how to read and write to the tag it, the Texas Instruments IS15693 tag. Thanks for watching.